So here we have a couple examples of simplifying radical expressions that involve some dividing. So a little important thing to note is that when we have radicals that are separated, it's useful to combine them first because then we can actually do some cleanup to them. That saves us some steps, all right? So if we have these two square roots divided, that's the same as the square root of 40x to the fifth divided by 2x. And then that just divides out. We can divide that. This is 20 and x to the fifth divided by x to the first. Remember, we subtract exponents when we're dividing. So this is going to be x to the fourth. And we still got the square root. And now it's time to simplify this. So to simplify this, we're going to use the radical product rule. We're going to break it into things we can square root and things that we can't. So can we square root x to the fourth? Sure. X to the fourth, because that's x squared squared. Okay? In fact, I'll go ahead and write that as x squared squared. Kind of an optional step there. But then 20 is 4 times 5. So 4 we can take the square root of, but 5 we cannot. So the radical product rule says if these two things are separated, 4 times 5 is 20. We can put them under one square root going this way. So we're going backwards, we're separating. We choose 4, not 2 and 10, because 2 and 10 cannot be square rooted. So we leave the 5 alone, and then we're going to square root each of these pieces here. That is multiplication there. Square root of 4 is 2. Square root of x squared is x squared. That's the idea. Now, we want to do the same thing here. Again, it's a good idea. They're both cube roots. Notice that. They're both the same index. So we can put them together under one radical. And we'll cancel what we can. Might not be everything. But 48 and 6 can cancel. 6 times 8 is 48. X to the 8th divided by x to the first. We subtract the exponents. That's x to the 7th. Now, if we subtract here, y to the first minus y to the fourth, that becomes y to the negative third, or think of it as one of these y's is canceling with one of those, leaving y cubed on the bottom. Now we have to ask ourselves, well, first we've got to break it up, and then we'll ask ourselves what we can cube root. Cube root at the top, cube root at the bottom. So we're using this quotient product or quotient rule twice. We'll put it together, and then we'll take it back apart. Now we see that on the top, we can cube root 8. But we cannot take the cube root of x to the 7th because it's not a multiple of 3. So we need to write this as x to the 6th and times x to the first. Now 3x cubed, that's great. 3y cubed actually, because they're the same index. That's just going to cancel here. And once we're getting the hang of things, we'll probably be able to skip this step here, but I'll go ahead and write it out just to be real clear. 8 is 2 to the third, and x to the 6th is x squared to the third. So that's what we're going to need there. We've got x squared, a multiple of 3 here in the index, or the exponents. And so we have this. Again, that's probably a step we can skip. I want to be very exact there. So cube root of 2 to the third, we know that. Cube root of x squared to the third is x squared times x all over y. Now, by the way, you'll see sometimes people will write this out as 2 times 2 times 2, x squared times x squared times x squared, something along that line. But that's a bit of extra tedious writing that we don't need. So there you have it. So again, a reminder, If you have two square roots being divided, put them together, clean them up, or divide the fractions, simplify the fraction, then you can simplify the radical. And that'll get you there. Hope that helps.